as we go. Okay, so let's get going. So the other thing I wanted to point out is I want to start with just two questions. If lines are parallel, what does that mean about their gradients? Put your answer in the chat. This is going to come up later in the lesson, but I wanted to just get it there right now. So if lines are parallel, what does that mean about their gradients? So often you'll see two parallel lines like that. So parallel lines, you're quite correct, have equal gradients. And so that's something which is going to come up in the lesson today. And then the other thing that's going to come up in the lesson today is something called the angle of inclination. And I'd love to hear somebody describe, if they know, what is the angle of inclination. So put your hand up and I will unmute you, and then I will draw what you describe. So I'd love to hear a voice if someone's feeling brave enough. Peng, I think, is the person that is going to raise their hand. I'm going to try and unmute you if I can. Peng, I'd love, what is the angle of inclination?
Yes, sir. Can you hear me, sir?
I can hear you loud and clear.
Basically, sir, an angle, how I know it, like, is an angle where, like, a positive, is an angle, a line mixed with a positive gradient.
Okay, you're almost there, you're perfect. So it definitely starts at what's called the positive x-axis. And if you have a line, the angle of inclination is how big is the angle measured from the positive x-axis up to the line. And when we were doing the trigonometry section, we might have called this like 0 degrees. And so the angle of inclination would just be the amount of this angle. If the graph was facing another way, so if the graph was facing like, if the graph had a negative gradient, in fact, let me take this back for a second. So if we have something like this, if we have a straight line like that, then the angle of inclination would just be like that. Or, you know, it basically, it goes from the positive x-axis to the line is the most important thing. And so later in the lesson, I'm going to talk to you about an important formula that when we deal with the angle of inclination, there's a formula called the tan of theta equals m, where m is the gradient of the straight line. So if you imagine, like in this picture, the gradient here might be like m is 2, and the gradient in the second one might be m is minus 2. We're going to learn about how to relate this formula to this idea of the angle of inclination. Now, you don't have to know it yet. I'm just kind of warming up and giving you a preview of where we'll get to later in the lesson. But for now, what I want to do is I just want to practice something from the end of the last lesson. And in the last lesson, I said to you that I taught you how to find intersection points of two straight lines. And for those who are able, I would like you to try and find the intersection point of these two straight lines. For those who are still a bit unsure, I'm going to give you some hints, but I want you to just think, what did we do at the end of the last lesson? So, and try and find these intersection points. Okay. And if you are stuck, I'd love you to just raise your hand, and then I can unmute you, and maybe we can even have a little conversation about where you're getting stuck.
Let's go, guys. Let's try this.
Yeah, because we know if we learn something, forget it a little bit, and then come back again. If we can do it again, then it really gets stuck in our brains, and that's fantastic because it's like no stress marks when it comes to exams. Okay, David, I'm going to unmute you. Go ahead, David, and let's have a chat.
Okay, sir.
Yeah.
Sir, are we gonna subbing this y equation to the first equation?
Okay, you're quite correct, David. And I want you to ask you, David, of these two equations, which one looks easier to you? To me, I made quite a big deal about substituting in the easy one into the hard one. Which is the easy one of these two?
David.
Okay.
So
Okay, so
what I
y
want to
equals,
say is, yeah, go ahead, David. Sorry.
okay, so the easy one is y equals to negative 2x plus 5.
Perfect. Yes. And often I call that equation 1, and then I talk about equation 2, and you're quite right. You have to sub equation 1 into equation 2. And what I said in the last lesson is I then go to equation 2 and I open up a big space where I'm going to sub the easy equation. And that's where I want to leave it for now until I start to see answers coming through in the chat. So back to you guys. Keep on working. Thank you, David. That was very helpful.
Well done, David. Let's go, guys. Woo, answers are coming.
Okay, so what comes next? And when you have got the answer, please put it in the chat just so I can get a feel for where you are in this journey. I'm going to catch a few of you with this one. And then what am I going to do? I'm going to take away 10 from both sides. Okay, so a lot of you have got X is 3. I'd love to know from someone in the class, how do I get Y? If someone would be willing to raise their hand, that would be awesome. What do I need to do to get I got the X part of the intersection point. How would I get Y? So Tsepang, I'm going to ask you to unmute. Could you just give me some guidance there?
Hi, sir.
Hello.
So the way I got Y, since I have the answer for X, I just used the second formula. So the Y equals to minus 2X, because it's already like, it's an easier way to find Y.
Perfect.
So
yeah,
I just substituted the 3 into the X, and then that's how I just got my answer.
perfect. And so I assume, Tsepang, you got, if I'm doing it now, minus 6 plus 5, did you get minus 1?
Yes, sir.
Perfect. So your final intersection point is 3 minus 1. And that's where the two lines would meet, which is fantastic.
Well done, Zapang. Well done.
Okay, so I just want to, before we move on, this is a very much a process that we go through. So the first one is we have to basically find an easier of the two equations. If they both look hard, then you have to just choose one. And you have to sub one equation into the other. And then once you've done that, when you sub in, you eliminate one of the variables, and that allows you to solve for something. And then the last step is to sub back into the original equation to help you to find the other variable, in this case, which I did here. Okay, fantastic. Okay, then let's just do a quick multiple choice question just to get things, because I do love a good multiple choice question. So can you move this out the way. Can you guys give me the answer to the question currently on the board? What is the equation of the line that you see in front of you there? Which of the four is it going to be? Because analytical geometry is a lot about knowing straight lines really well. And pop your answer in the chat. So for those who can't see, this is a 3, what we would call the y-intercept. So what is the equation of this line? Is it A, B, C, or D? The other thing that's very important with straight lines is the gradient. Is it possible to work out the gradient of this line? I think it might be. So the gradient to me, this is a positive gradient. And if I go between these 2 points, it looks to me like I go 1 across and 2 up. So the gradient is 2, and the y-intercept looks like it's 3, which would mean y equals 2x plus 3. Okay, fantastic. And I see everyone pretty much has got that right. And if you haven't, just think about the reason it can't be A or B is there's no y equals. You need the standard form of a straight line. Okay, let us do one more multiple choice question. And then we're going to move on. So it says a line has the equation 3x plus 5y equals 7. I want to know what is the gradient of that line. And now there's no picture. Okay, so now think about what you know about straight lines, what you know about standard form, and see what you can work out, and then put your answer in the chat. Okay, a couple of different options coming through. Keep the answers coming. I would say that this is not in standard form at the moment. And if only there was a way I could change it from non-standard form to standard form. That would be so helpful. Okay, give a little bit more time. So I think standard form of a straight line is when I have y equals something, x plus something. And if I get it into that form, I know that this number over here, this m, is the gradient I'm looking for. So I'm going to try and rearrange this equation. And what I'm going to do is I'm going to move this 3x. And in order to move it, I have to take away 3x from both sides. If I do that, I'm going to get that. And in fact, I'm not even going to write it like that. I'm going to write it with the minus 3x in front. And now this pesky 5. Now, a lot of you are going to get caught with this because you get that part fine. But now the y has to divide not just the 3, also the 7. So when I divide minus 3x by 5, I get minus 3 over 5x. But I also need to have 7 over 5. So think about that for a moment. Can you see how it's this 5 has to give attention to minus 3x and 7. If I ignore 7, 7 is going to be upset. So now out of those options, this is going to be the gradient. It's going to be minus 3 over 5. And guys, this is a tricky question. I chose it on purpose, but just to show you how rearranging a straight line into standard form, that can give you the gradient, which is B. Yeah. And so Vidad, the reason I'm dividing by 5 is because this 5 is right next to the y, and the y in standard form, y is all by itself. Okay. And the reason it's negative is that when I brought the 3x across, basically it had to become negative. Now, look, don't feel bad if you got that wrong, because that was deliberately set up to sort of be thought-provoking. So I was hopefully being a good teacher by laying a little trap for you that's going to help you in the rest of the lesson. Okay, let's go to parallel lines. So I want you to quickly give me a vote on this. A line parallel to this would have a gradient of what? I want you to vote. We're in the chat, A, B, C, or D. So I'm giving you a straight line, and I want to know a line parallel to this would have a gradient of what? Okay, I mean, this is like piece of cake, right? Almost piece of cake, so it should be 3. So any line which is parallel to this will have the same gradient. What is the gradient of this line? It's 3. So the gradient of any line parallel to it must be 3. Okay, fantastic. So example number 1, I'm going to do the one on the left, and then you guys are going to do the ones on the right. So it says, the question says, determine whether or not the following two lines are parallel. So let me zoom in for a second, just to focus on this before I'm going to do this one for you. At the moment, if I look at these two straight lines, I do not know what their gradients are, but I do know they're straight lines because they've told me in the question, and I can see they both have X's and Y's in them. So what I'm going to do is I'm going to rearrange both to standard form. And so if I rearrange this very first one, it should look like this. Y equals minus 2x plus 1. And now the good news is I know the gradient of the first line is going to be minus 2. Then I'm going to look at the second one over here and go, actually, it almost isn't standard form. It's just written in a confusing way. If I wrote it with the Y on the left-hand side, I can clearly see that that's the equation of the blue one here. Now, what I notice is the gradient is also minus 2. And so I can then say, oh, no, it's too thick. It feels like I've got the wrong type of brush. The two lines are parallel because M equals minus 2 in both. Or often we would just say equal gradients. The short reason often we would use is just say equal gradients. Okay, so that's how we would prove that these two lines are parallel. They have equal gradients. Now, I want you guys to try and answer the question on the right-hand side now. And then if you think they are parallel, let me know in the chat. If you think they aren't, let me know in the chat. And I'm even going to give you a second one. Actually, no, not yet. Let's just do this first one by ourselves first. So over to you guys. I want you to work out, are these two lines parallel or not? And I want you to attempt that. I'll give you 2 minutes for that.
Let's go, guys. Woo. We still have an example there that Teacher Peter did, so it should be easy peasy. Let's see.
Yeah, we'll use the structure on the left to help us. Are you having flashbacks to your school career, Yolanda? Are you?
Yes, I'm learning. I'm learning. I'm like, whoa, I'm ready to answer this one. Thank you.
Cool. So what we really need to think about is what is the gradient of these two lines and how do we figure out whether or not they're parallel? That's what we need to think about. And I think these lines are not in a nice order. It's almost like you have to play with the order. Okay, I see some answers coming through. So while you keep working, I'm just going to do a little bit of working out on the first one and say, if I take away 1 from both sides, the very first one should have a gradient of 1. And then the second one.
So,
sorry, Teacher Peter. So the first one, when we're removing our 1 to the other side, I think we forgot.
Oh, you are quite right. Thank you so much.
I got it right then.
No.
I'm happy.
Yeah, no, that was well done. That was, see how you make those like silly mistakes. I think what happened was my brain went to writing a 1 in front of the X. And this is important because students will say, well, if there's nothing there, what is the gradient 0? And it's not. The gradient is 1. But now if we look at the other one, we have to move the X across and it's minus X, and make sure I don't make a silly mistake. It's plus 3. So in this one over here, the gradient is 1. In this one, the gradient is minus 1. And so are the gradients the same? They're not. So we can say lines are not parallel. And you can just write different because different gradients, or you can say, yeah, I suppose I should use a different letter if they're different. So we call M1 and M2. And so they're different. Okay, well done. I think most students seem to get that right. So let's do another question a little bit like this. But I feel like you guys can do this one. I'm not even going to do the example. So the question has been changed slightly. So it says determine whether or not the following two lines are parallel. And I want you to think back to previous lessons and ask yourself, what do you need to think about? And then I'll wait for the answers in the chat. What I will give you is the formula for a gradient. The gradient formula, which is given to you on formula sheets. Think about, can you know the gradient of this one? Can you know the gradient of this line? And if you need a hint, then just raise your hand and I will look at the chat. Okay, so let's have a look. If I could just get my Latifa, if I could ask you to unmute and to just ask a question. Latifa, go ahead.
So can you please explain the question again?
I can. I just want to ask you, Latifa, do you know what the gradient of the first line is? Can you see what the gradient is there?
Isn't it 7, -7?
It's not -7 because the second part here is actually the y-intercept. So it's the number in front of the x, which is the gradient. So that's the first key step. The gradient of the first straight line is 2.
2.
Now you need to compare that to whatever the gradient of the line going through these 2 points is.
Okay, thank
you. Does
you.
that kind of make sense?
Yes,
Pleasure.
sir.
So now I see quite a few answers are coming through. And what I want to point out is that I know how to find the gradient between 2 points. We did this in previous lessons. So what I'm going to do is I'm going to work this out. So I'm going to go, I always start, I go -1. I've got to watch out for the double minuses. They can get tricky. So -1 minus -2. And then I'm going to say 1/2 minus 1, which is then going to give me, now this really is a sneaky one, isn't it? So -1 plus 2, that's 1 over -1/2. And if you need to use your calculator, that's fine. Or you can just, so you should get -2. So, in fact, you guys, you know what, you could have put in your calculator earlier in the question. But the main idea is that the lines are not parallel because the gradients are different. So it's not parallel. Okay, let's do another one like this. And I'll zoom out a little bit so that you can see the old example. And then let's just do one more like this. And then I think we're ready. So determine whether or not the following the line through the points -2, -1, and that line are parallel. And I'm going to keep quiet for 3 minutes while you go about figuring that out.
Well done, guys. I think the example that we
well.
just did now, you did really well. I saw some positive answers on the charts. That's really nice. Let's try this one. Let's go.
Yep. Let's do it.
Remember, if you are confused, you can send some questions. You can ask questions. We are here to help you.
So guys, if we look at these two questions, and I'm open to, if there are questions, pop your hand. If you want to ask a question, pop your hand up in the chat. But for me, what I did was I first looked at the straight line. And I said, look, if I can just get the straight line into standard form, then I'll know what the gradient is. And so what I did was I just basically moved the y across to the other side. And then I rewrote it so that I knew, look, this is standard form. And then I said, well, what's the number in front of the x? It's 1. Okay, so I know the gradient here is 1 in that side. Then on this side, I had to do 2 points. So I went -3, -1. And then I went -4, -2, which is that. And I basically get -2 over -2, which is 1. And so the lines are parallel because the gradients are the same. I feel like we should do just one more of those. I feel like we just need just one more just to make sure we can do these. So I'm going to move this out the way. Oh, I'm trying to be too clever, guys. This is what happens when you're trying to be too clever. You try to do too many things at once. There we go. So I'll leave that one above up for you. I'll zoom out a little bit. And then I want you to try and find if these two, I know, Yolanda, thank you, I appreciate it. This is not easy, moving things around, like balancing the, so are these two lines parallel? So you're given that, and then the line passing through those 2 points. Over to you guys. Yeah, no, totally. With maths, guys, honestly, it's about practice. The more practice you have, the more your brain puts the pieces together and you start to actually enjoy it. It really is about that.
Just want to shout out to Nokulunga. Nokulunga, you're getting there, girl. You're getting there. You'll get it right. Exactly. Let's do this, guys. Let's do this. Remember also to follow the steps that teacher Peter showed us, because for me, it's so helpful.
So Yolanda, would you, out of the two sides here, where would you start first? Would you start with the y minus 1 equals a third x, or would you start with the points? There's no
I will definitely start with the y minus 1 equals to put it in standard form, because that's what you just taught us here at the top. So I'm learning a lot. Totally. Definitely.
Because it feels like I should put that in the bank first, right? I've got 1 mark in the bag. Now I'm going to maybe go to the slightly harder parts, but why risk it? You know, let's get the easy stuff done. 5 minus 4, and then we're going to get 3. What are your answers going to be, guys? So I agree. The gradients are the same, so they are going to be parallel. Perfect. Okay, we're almost done. In fact, I'm going to push the break back a little bit because you guys are doing so well that we can actually finish this topic, this sort of part here. And so what I want you to do is I want you to try and do this question over here. Apologies if I'm, so I'm gonna jump a little bit, pushing you because you're doing so well. This is where you are going to write down the equation of a line that is parallel. So you're writing down the equation of a line, a different line, that is parallel to y equals 6x plus 1. And you know that this line that you're looking at, it passes through the point 0.8. Now, I'd love for someone to jump online and tell me, why do you think they're giving, in this question, why do you think they're giving you the y equals 6x plus 1? Like, how are you going to use that? If you're willing to contribute, just put your hand up. And the goal of this question is to write down the equation of a line that is parallel to y equals 6x plus 1, but also passes through 0.8. And we're using something that we've done in previous lessons here. So put your hand up and I'll unmute you. Or who is feeling like they can tell me what's the y equals 6x plus 1 doing? I seem to have lost. Let's see if I can see the visual. Who's got the hand?
Kiriboni has her hand out. Should
Go
I
ahead.
unmute her?
Yeah, let's unmute her. Yep.
Afternoon, sir.
Hello.
Or evening. So the equation is to tell us that m is also equals to 6.
Perfect.
Right? Should I carry on?
So exactly. So the main value is just to realize that if it's parallel to this line, this new line that I'm trying to find is going to have a 6. And so all that I really need to do now is I need to figure out what the C value is. Okay. Now, there's different ways of doing this. Some of you will recognize that the point 0.8 is the y-intercept. But what I've done in the past when teaching this is if I want to figure out an unknown, and I did this in previous lessons, I just write down the point next to the equation. And then I take this point and I sub it into the equation of the straight line. So remember, this is x and this is y. And so if y is going to be, let's have a look. So 0.8. So y is going to be 8 and 6 is going to be 0. Well, if anything times 0 is nothing, and so C is going to be equal to 8, and the equation of my line is going to be y equals 6x plus 8.
Mm-hmm.
So I have to then figure out in this question, not just use the parallel line idea, I had to figure out the equation of the straight line. Now, for those people who used a different method, that's not a problem. I will use different methods in future, but I just want to, I'll try and do one each time. And guys, I know that I'm sounding like an overhyped teacher here, but you have done so well. I want you to do one more for me. And so let's do one just like the one we've just done, except a little bit, well, not even harder. I'd say it's about the same. So determine the equation of the straight line that passes through the point 1 minus 5 and is parallel to this. And while you work on that, I will take some questions from students if they have any. So Tsepang, your hand is up. Go ahead and ask your question.
Sir, going back to the question with the y equals, okay, that question, why isn't it negative 8? Because it seems like the y is on the other side of the equation. So when you bring it this side.
Okay, good question. First of all, let's just make sure we all agree with the original bit. So the original bit, we know the 6 is there. And so we have to sub in the point 0.8. We know that the 0 goes over here and that the 8 goes here. Now, what happens is the only goal that I'm interested in right now is finding the C value. And so when I multiply 6 by 0, 6 times 0 is nothing. It's literally nothing. It's 0. I could rub it out. So now I'm only interested in what C is. And because this is an equation, I don't need to move anything around. I just go, well, C is on this side and it's equal to 8. So I don't need to think anymore. I was only interested in 8. So I'm going to replace the C value here with an 8. So it's just about where you are in that process. Yeah. Okay, so I hope that was that help, Tapang? Was that okay?
Yes, sir. Thank you.
Pleasure. Okay, let's have a look at the next one. I see some answers are coming through. Now, whenever I start my journey, and I think this is just a habit my math teacher drilled into me, I just start by thinking about what am I looking for? And so I write down mx plus c. But I know some of you also use this formula, and that's also fine. So you might be starting like that. Both are completely fine. Both cases, I need this magical gradient. And so the way I'm going to get it is this piece of information here. And so I'm going to say it is parallel to that line, but that line is not in standard form. And so I'm going to move things around to be like that. And what that means is that this gradient is -2, as long as I haven't made a silly mistake. Yes, okay. So I know that when I solve for this, in this method, I'm going to have 2x plus c, and then I would choose the point. I need to use this point here to help me. So what I do is I write it down over here. For those who are, I'm actually going to move this -2x plus 1 out the way. For those who are using the other method, you also have, what was the gradient? I've just forgotten it. I've just rubbed it out. Let me bring it back. The -2. Look at that, magic tricks. Okay, so -2 is, so this should be -2, right, Yolanda? That was -2 that we worked out previously.
Yes, our gradient is
It's been a
-2,
long
so
day.
that's correct.
Yeah. So for those who are doing it this way, you would say, you're also going to use the point 1 minus 5, but you would just have x minus 1 here, and then you would have y minus your -5 up there. So I'm trying to do both ways so everyone can kind of see. But I would suggest you guys pick one way of doing it that works for you. So on this side, I'm subbing in my -5 in here, and then I'm going to put a 1 in there. And now I need to find c. And so the problem is I need to get this -2 across. And so I'm going to add 2 to both sides. And if I add 2 to both sides, I get -3 is c. And so my answer is y equals -2x minus 3. So that was the one way of doing it. And then the other way, for those people who are doing it the other way, y minus -5 is y plus 5. And then I multiply the -2, so I get -2x plus 2. And then I take away 5 from both sides, because there's a 5 here. And if I take away 5 from both sides, I get -2x minus 3, which, lucky for me, guys, is the same answer. Because if it wasn't, there would be a problem. So, cool. Lorato, you have a question?
Yes, sir.
Yeah.
Why do we have to add 2 on both sides?
The reason I was adding 2 on both sides is that I was trying to undo this -2 over here. Because basically this -2 plus c, I want the c by itself. I want it to be isolated. And so what's the opposite operation of -2? It's going to be +2. And so I added 2 to both sides because I knew -2 and +2 would be 0. That was the root. Guys, I've been a bad master today. I've pushed you through your break, but I fear that now that we've done it, we're just going to keep swimming. Or actually, you know what? It's never too late for a break. We've got a bit of extra time. Let's take a quick break, a quick brain break. Have I got a quiz picture? Let me go and grab it very quickly. let me just go and find it quickly, and then I will put it on, because I feel like our brains need a brief break from all this learning that is occurring. Number patterns, and I'll be with you right now. Okay, and then so we're not going to be standing up today, but what we are going to do is one of those wonderfully addictive number puzzles. And there it is. So let's have our break because we've earned it.
Woo! Let's quickly get this one, guys.
Latifa, you can ask a question while students are working on the brain break.
Hello.
Hi,
Hi,
go ahead.
Latita.
So I want to ask, I bring back the 2x if you cancel the 2.
Yes. Say that again. So how do you cancel the 2?
We canceled the 2, ne? And then
Yeah.
you brought back the 2x. Why?
Yeah. So let me, while students are working on that, let me just zoom in a little bit. So where about am I losing you, Latifa? So
y is equal to 2x plus c.
minus 2x
And
plus
then negative. Yes. Why bring back the 2x here at the end?
Oh, okay. So the reason I brought it back at the end was the goal of the equation was to find so in the question, it says determine the equation of the straight line. So even though I'd found what C was, that wasn't the answer to the question. The question was, give me an equation of a straight line. And so that's why straight lines have the standard form mx plus c. Okay, are answers coming through for the brain break yet?
Oh, yes, yes, yes. My
Okay,
people are
you
so
got it?
good.
So you should see that this is 5. And if that's 5, let's see if people have got the next bit. Oh, I see lots of people have got answers. So this should be 2. And then this should be 1. Yeah. So the red triangle is equal to 1. So well done to Notile, Siabonga, Teddy. Lots of you got that right.
Yeah.
I think
Well done,
next time
guys.
I need to take it up a notch. So well done to everyone there. Okay, let's just do the last part of the lesson. We're probably going to have to not do the whole thing yet. But one of the things I said in the previous lesson, well, at the beginning of the lesson, was we're going to start working on this angle of inclination formula. And basically, if you think of the way the formula works is if you imagine a straight line, like we were working about, you can imagine that we can work out a gradient for most straight lines. Okay, in fact, let me get rid of this bit. So you know that we can work out the equation of this line and it will be, let's say, for example, this would be m is 2. Now, the formula for the angle of inclination is m equals tan theta, where tan of theta is from trigonometry. Now, how in the world is that working? And I wanted to show you what the connection is. So if you imagine a triangle being formed along here, then I want to suggest that if the gradient of the line is, I know I didn't draw it very clearly, but if the gradient is 2, it would mean I would go 1 across and 2 up. So I just want you to think about for a moment, can you see how if I formed a triangle that, and the gradient was 2, that the triangle would have a 2 going up and the 1 going across? Give a thumbs up if you understand what I mean by that in the chat. Can you make the connection between a triangle being formed on a straight line and the fact that if I know the gradient of that straight line, then I know that essentially the ratio 2:1 would be there. Okay, good news. Now, it's actually from trigonometry. Okay, so if you think about gradient is just rise over run. And so that's the other way of saying it is if I know the gradient of a straight line is 2, I know that I have to go 1 across and 2 up to get to the line. Now, if I build a triangle, if we use the language of trigonometry, and this is a right angle, then this would be called theta, or the reference angle, and this would be called O, this would be called H, and this would be called A. And so what is the trig ratio that deals with O and A? If you were in the class for my earlier module, you would know that the trig ratio that deals with O over A is tan. And so we can say that, and again, we're just going to start using it today, M is equal to the tan of theta, or the gradient is equal to the tan of theta when dealing with straight lines. Okay. Now, how do we actually use this? Because that's a little bit, I will go over this again at the beginning of the next lesson. Okay, so you don't need to stress about this. This is the first time you've heard about it. But the way I would use this is if I know that the angle of inclination is 60, the angle of inclination is the theta in this triangle. So, for example, if I'm given the angle of inclination of 60, what is the gradient of my straight line going to be? It's just going to be the tan of 60. So the answer would be the tan of 60, my gradient would be √3 or 1.73. Okay, if I wanted to find the gradient for a straight line with the angle of inclination of 135, and I'll even visualize this for you. So if the angle of inclination was 135, it may look a bit more like that. So you can imagine starting here, and that angle is 135 degrees. Well, in that case, the same formula is still going to work. We're going to get, what's the tan of 135? The tan of 135 is equal to -1. Okay, so I just want you...
Sorry, Teacher Peter, to disturb. Can we zoom in a little bit on this section of example #0? Yes,
okay.
Thank you. Thank you. That's perfect.
All I'm doing is I'm using the formula M equals tan theta, which is a formula that we use for the angle of inclination. And if the question says to you that the angle of inclination is 60, then to get the gradient of that straight line with an angle of inclination of 60, I just put that into my calculator, and then the gradient when the angle of inclination is 60 is going to be 1.73. Now, if they tell me the angle of inclination is 135, which I tried to visualize for you here, it's going to mean the graph has a negative gradient. You can see that. All I did was type tan 135, and I got my gradient was -1. Okay, now I want you guys to try and work out the gradient of a line with an angle of an inclination of 54, and then also the gradient of a line with the angle of inclination of 140. And once you've done that, I want you to put that in the chat. I know I'm squeezing this in, so I will start the next lesson. With this. Remember, this is normal trig. So we just use the simple formula, M is tan of theta, and it helps us understand the angle of inclination relationship to gradient.
Let's go, guys. Remember, we are allowed to use calculators.
Yeah, I would recommend using calculators. Okay, so what do I get for the first one? Tan of 54 equals, the gradient here is 1.37. So that is the gradient for this one. And what is the gradient for this one? Yeah. Pop it in the chat. So the tan of 140, still wait a little bit more. So if I round it off to 2 decimal places, I should get minus 0.84. Some of you are giving minus 0.83. That's perfect. Okay, so to almost end this lesson, if we want to relate angle of inclination to gradient, we have this handy formula. Now, what happens if the question is a little bit reversed? Well, the good news is we still use the same formula. But now, if I'm given the gradient, so here was my formula, m equals tan theta, but I'm given this time, I'm given the gradient, and I have to work out the angle of inclination. Well, what I'm going to do is where the gradient is, I'm going to put 4/5, and then I'm going to write tan theta. But the problem is, I now have to find the angle of inclination, and I can't just click tan. Who would like me, Renelewe, could you tell me what I need to do with my calculator to get the angle of inclination in the formula?
Can you hear me, sir?
I can hear you loud and clear. What do I need to do?
All right. Okay. So I'm using the Casio. So should I just explain the steps that I'm doing?
Yeah.
Okay. So what I did, I pressed shift and I pressed the 10 sign, and then I punched in 4/5, which is like the inverse of the normal 10, and then that gave me 38.66, I believe.
Yeah. Perfect. So what you've done now is you've managed to use the gradient to find the angle of inclination, which is absolutely okay. Let's try and do one more. Let's see if we can do, if I give you a gradient of 5.69, what will the angle of inclination of that line be? So, if we're visualizing this, a gradient of 5.69, that's quite steep. So it's probably like a line with a gradient of 5.69. What we're trying to work out, and we're using the magic of trigonometry, is what is this angle over here? And so I use my faithful formula. 5.69 equals tan of theta. Who would like to, Nontokozo, would you like to help us do this last question of the day before we go to Quizland? Can you hear me, Nontokozo?
Oh, yes. I wanted to ask,
yeah.
I wanted to ask, to find the inclination, use 10 only.
Yeah, you only use tan. There's in the next lesson, I'll talk to you about what happens if we have a negative gradient. There's a slight change of process there, but whenever you deal with angle of inclination, you're always going to use this formula, m equals tan theta. And this goes back to the thing I said at the beginning of the lesson, where I said, if you think about 2 points, if you take these 2 points on the line and you draw a right angle triangle, then you know that gradient is just how much, it's basically just rise over run. But it turns out that from trigonometry, rise over run is the same as O over A. And so we connect the two worlds of gradient and trigonometry, and we get this wonderful formula called m equals tan theta. Okay, do you have the answer for this one, Nontokozo?
It's 80,03.
Perfect, exactly right. And that makes sense because we expect the angle to be quite big because it's a very steep line. If we'd got something like 15, we would have been a bit confused because how would you get such a steep line? Okay, everyone, you've done exceptionally well today. We've covered a lot of work and we've really started to get into the meat of the section. And so what I'm going to do is I'm going to set you a quiz now. There might be a couple of questions with the m equals tan theta with a negative gradient. If there are, don't stress. We'll talk about them next week, and don't stress about it. But do the best you can in the quiz now. And Yolanda, if you could just put the link to the quiz in the chat for the students. And well done, guys. You must be feeling tired now. That was quite a session. And
yeah. Well done, everybody. You guys did really, really well. Oh, so proud of each and every one of you and everybody who tried. Remember, you can always get this session or this lesson on the website. And if you do need the link and you can't find it on the website, let me know and then I'll post it. But for now, remember, there's the quiz there and I've posted the quiz.
Perfect.
Right there.
Yeah, thanks, David. It's been, I hope you enjoyed it. Mawazi, I'm also tired. It has been a long day. And I think it's nice to end with that sense of achievement though, like you've done something good, but I think we all need a nice break now. And for our brains to pack this knowledge away, organize it so we can retrieve it again. Well, okay, you guys are doing the quiz. Apologies before I make your life miserable, but after the quiz, the break is starting.
Yeah. It's a nice quiz, guys. You'll enjoy it.
Oh, and just a reminder, sorry guys, some of you are doing an exam revision course on the weekend, so we do know about that, but we mentioned that on Tuesday. All right. Are there any questions from students? Retabile, I think I'm going to let you unmute. So I'm going to unmute you now. Go ahead and ask your question.
Sir, I'm sorry. Can we go back to the parallel lines?
Yes, we can. So which part of the parallel lines question? Yeah.
I don't remember which question it was, but
okay,
yes, this one.
The one that you in front of you now.
Yes, sir.
Perfect.
So is it okay if we just transpose -2 to -5 so that it could be +2?
So say that again. Where are you?
Instead of adding +2 on both sides.
Yes. Yeah.
Can we just transpose -2 to -5? Then it will be +2.
So, okay, let me draw out that step just so we're clear. So you're saying when we have -5 equals -2 plus C, you want to bring the 5 across?
Or just the 2 across?
So if you bring the 2 across, okay, you still have to change the sign. So you get that.
Yes, it will be +2.
Yes, that's fine. And it gives you the same answer. What you're doing is you're just using a shortcut. I always emphasize to students, because when you deal with an equation, it looks like what you've done is magic there, but all you've really done is you've added 2 to both sides. It's the same operation. It's just that I am showing more of my working.
Okay, thank you, sir.
Okay. Notile, your question, I'm going to unmute you now.
Oh, hello, sir.
Hello. How's it going?
I wanted to ask the Saturday examination preparations, at what time will it start? And
it starts at 3 o'clock, if I'm remembering correctly. Yeah. 3 toppers 4, if yeah.
Okay. Thank you, sir.
Pleasure. Any other questions before we call this a night? Latif, I think I'm saying it wrong here.
Latita, I don't know also.
Latita.
Or Lilita, actually.
How do we pronounce it?
It's Lilita Latita.
Latita.
Ah.
Yeah, there we go.
Lilita.
So can I please ask when are we doing Euclidean geometry?
Okay, the good news for you is I've done 10 lessons on Euclidean geometry that are on the Watobe website. So I'll even show it to you very quickly. Let me see if I can show it to you. Then we must go. So I'm just going to take you to the Watobe website. Watobe. So all you need to do is go back. We have some exam revision classes on the weekend where we will go over some of that circle stuff. But I have also done a whole module on let me just show you. Share screen. So on the classes, can you see the Watobe website?
Yes, sir.
So if you go to grade 11, you'll notice that there's circle geometry here. There's the topic circle geometry.
Yes.
And I have done a whole bunch of lessons on that. Now, obviously, it's a lot to just suddenly watch all of a sudden. It's not like doing so on the weekend, we'll do a shortened version. But if you're starting and you're really struggling, this would be a good place to start.
Thank you, sir.
Pleasure.
I'm also just putting the link there for you if you want to use that link.
Okay,
it will
last question of the day.
to...
So what topics are we going to do on Saturday?
So I'm still finalizing my topics, but let me just look at my planning. So I'll do a mixture. I'll probably do, let me have a look. So I'm going to, at the moment, my intention is to do equations and inequalities, some trigonometry, and some analytical geometry. And that is my...
The nature of roots.
Nature of roots is in equations and inequalities. So we'll touch on that. So
Yes.
nature of roots is part of general algebra. And so we'll talk about things like inequalities, nature of roots.
And trig functions.
Trigonometry, we'll talk briefly about trig functions. I don't know how much, won't go into detail because there's quite a lot in trig, but we'll definitely touch on trig functions, an exam question on trig functions. Yeah.
Okay, thank you, sir.
Cool. All right, Yolanda, I think it's time for a break. So we are going to end the meeting.
Yes.
Have a very pleasant rest of your evening, and I will see you soon.
Thank you.